Yo, yo! Chapter 11, Section 2, Box-and-Whisker plot. Well, Box-and-Whisker plot. This is probably the cutest name for a lesson. Oh, Whisker is like a little kitty. All right, how do I display data in a Box-and-Whisker plot? You have seen this before, way back when you were wee little lads in Math 6 Accelerated. Or wee little laddies? I don't know, man. I don't speak any of this. All right, let's just get to it before it starts getting weirder. Okay, Box-and-Whisker plot shows the variability. Wait, variability, that's related to the word variation. And we've talked about the measures of variation, adding, of course, the standard deviation of a data set along a number line using the least value, that's 1. The greatest value, that's 2. And the quartiles, there are 3 different quartiles, which are cuts in the data to make 4 sections. We'll talk about that more. But quartiles divide the data, wait, we're going to talk about right now, into 4 equal parts. It's got the cut in the middle, which is called the median, which is also the second quartile, Q2, and divides the data set in 2 halves. Then the median of the lower half of the data, so if you go below the median and you take the lower half of the data, find the median of the lower half, you get the first quartile, or Q1. And then the median of the upper half of the data above the median, right, is the third quartile, Q3. So let's take a look at these. There's 5 numbers that you need to know to make a Box-and-Whisker plot. The least value of the data set, the greatest value of the data set, then the number that's exactly in the middle, right? If the data are ordered from least to greatest, that's the median. And then you have the lower half of the data. The median of that lower half is the first quartile, and the median of that upper half is the third quartile. So 1, 2, 3, 4, 5. There's 5 numbers, and we call this the 5 numbers that make up a Box-and-Whisker plot, the 5-number summary of the data set. All right, let's do an example. Make, all right, a Box-and-Whisker plot that represents the ages of the members of a backpacking expedition into the mountains. Sweet. All right, let's talk about who is it? Oh, Hillary going up Mount Everest. Okay, so let's see, what's the least number? 18. And you guys are gonna be 18 soon, and you're gonna be like, I'm old. And then you'll start to get really old like me, and you'll be like, I'm even older. And then you'll be like, 18 wasn't that old. Okay, 22, 22. Boom, 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 ba-doop, boom, ba-doop. Looks like we got 2 22s. Wait, whoa, whoa, whoa. Look at that with the comma. Jeez, Mr. Plunkett, that's gorgeous. Okay, 24. You probably like this is excruciating slow. Go ahead and fast forward if you already like know what I'm doing here. Okay, 25, 25, 25. 3 25s. 25. Whoa, 25 and 25. Show me your life. 30, 30, 28, 30, 27. 27, 28, and then 30, and 3 30s. Wah and wah. One of the things that I do when I'm ordering a data set from least to greatest, besides using a sort algorithm inside my computer, is to count the number of data we started with. 1, 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Good. Make sure that the number of data in your list matches the number of data in the original list. Okay, 5-number summary, right? So let's start with the least value, the LV. That's the easiest one, 18. Then the greatest value, another easy one. That's just 30. Now we've got to get those quartiles. How many cuts does it take to cut data into 4 sections? 3 cuts. And the first one we're going to start with is the median, the good old median. And that's right in the middle of the data from least to greatest. I'm going to use my little dot method. Okay, 2 in, now 3 in from the outside, now 4 in from the outside, now 5 in from the outside. And then it looks like we have 2 numbers in the middle. The median would be a cut in between them. I should probably do that in red so you can see the difference. But I've made a cut in between the 2 25s. That's 25. And for consistency purposes, I'll use blue. For Q1, which is quartile 1, it's going to be the median of the lower half of the data. So I'll go back to red. And same thing, 1 in, 2 in, And then we have two numbers in the middle. That looks like it's going to be a number between 22 and 24. That's 23. And then we have the upper half of the data for quartile 3. Look at this. Okay, so going back to red. Okay, we're going, well, we already know from the last one, but it's all right. I'll show you that it doesn't matter. You don't have to think that hard. Okay, 28, between 28 and 30 is 29. So we have our 5 numbers. That's all the numbers that we need. The least value, greatest value, median, quartile 1, quartile 3. And then what do? For the least and greatest values, you put a dot above the number line. So a dot for 18, a dot for 30. And then for the quartiles, the 3 cuts, you put a line. So the median's at 25, so I'm going to put a line. For quartile 1's 23, I'm going to put a line. Hey, that's a beautiful line. And then quartile 3 is 29. Put a line, and then we connect these lines into the box. Oh, that box is just looking so good. That's a beautiful box. And then you make the whiskers. Oh, little whiskers. Oh, this one's gonna be hard. Hold on, I gotta have a good aim. Oh, yeah. All right. So here's the thing about a box and whisker plot that you may not have understood back in 6th grade, but hopefully you understand now. If you look at the 3 medians, the 3 cuts that we made, right? Look how much data there is in each section. There are 3 data values, 3 data values, 3 data values, 3 data values, okay? So on the box and whisker plot, it's showing that variability. It's showing how wide is this lowest quartile, this low section. Well, it goes from 18 to 22, right? Well, it goes up to 23 because that's where the actual quartile 1 is. But that means you have a quarter of the data, 3 out of the 12 total points is in this section. A quarter of the data is in this section from 23 to 25. Yep, from 23 to 25 is a quarter of the data. From 25 to 29, that's another quarter of the data. And finally, from 29 to 30 is another quarter of the data, which of course is just all 30s. So this is kind of showing you that we have a lot of data concentrated around 30, and then we have more variability down here. This 18 is really far below kind of a lot of the rest of the data. So these are sections, 25%, 25%, 25%, 25%. Test yourself. What percentage of the data are from 23 to 29? There's 2 sections, each one's 25%. 50% of the data should be between 23 and 29, and that's exactly what we see. Is that in this section, these 2, you have, this is the box right here. That's 50% of the data is just right there. And so this shows you where the middle 50% of the data are, which can be really helpful if you're trying to predict where the next value is going to be. It's like, well, it's probably going to be in that range, or has a good chance to be in that range. All right, that's awesome. That's the end of part 1. I'll be back for part 2 momentarily.